So welcome today. We are pleased
Mom,
to introduce.
and Julie.
Let me do the introduction, then you can talk. Sorry. Introduce Melissa Boyd. She is a grad student in the Department of Earth and Planetary Sciences, and she's going to be talking to us a little bit about the geology and paleontology of Kenya. So go ahead, Melissa. It's all you.
Currently not
Melissa, can you hear? Go ahead.
Yes, can you hear me?
Yes, we can.
Okay, hi everybody. My name is Melissa Boyd, and I'm going to talk to you today about the geology and paleontology of Kenya. Now, you guys already know that geology is the study of rocks, so we'll be talking about rocks, but we'll be talking about paleontology, which is the study of ancient life, and I'm sure you all know that, and ancient life includes all life before the Holocene, which is the time that we're in right now. But for paleontology, we also include archaeology, anatomy, ecology, and biological anthropology. So there's a whole bunch of ancient living things that we study. Like I said, my name is Melissa. I'm a grad student at Rutgers Earth and Planetary Sciences, and I study the geological context of evolution in Kenya, which actually just means that I study the rock formations around the areas where our human ancestors evolved. I work near Lake Turkana in northern Kenya. I love hiking, running, and cats. And my favorite rock is serpentinite, which is this cool green rock that you can see right here. And you don't find too much of that in Kenya, at least in the area where I work. Maybe that's why I like it so much. But additionally, you can see in my selfie here, this was the first time I saw a camel in Kenya, and I just thought it was so cool that I was so happy that I just took a selfie. Anyway, today, like I said, we'll be talking about the geology and paleontology of Kenya, and I'm going to start off with why the geology is so important. And in order to give you a quick review on why the geology is so important, we must quickly go over rifting. Lake Turkana is located in the East African Rift Valley, which you can see right here. This light green ribbon is the Rift Valley. And many of the fossils of our human ancestors are found there. While humans did evolve in Africa, the fossils are abundant because of the rifting, or at least because of the consequences of the rifting. About 25 million years ago, the African plate started separating into two new plates, or the lithosphere was being stretched. I think you guys heard about the lithosphere during Chris Rowan's talk. It's just the crust in the upper mantle. So that was stretching, or it is stretching, into two different plates, the Nubian plate and the Somali plate, and they're stretching in opposite directions. And what's happening is a rift valley is resulting. And what is actually happening, or will happen in about 10 million years, is that a new ocean will open right here. So right now we have an ocean starting to develop, which, you know, takes a lot of time, but that's what's happening. And right here I have a little animation that shows this actually happening. It's rifting right now, like right now as I speak, it's rifting. This little animation starts around the Eocene, which was 50 million years ago, and I'm going to go through it really quick. And you can actually see the rift starting to form and the plates pulling apart. It's definitely cool. Here we go. Okay, that's the Eocene. Now we're getting about 40 million years ago. You can see the rifting starting, the Oligocene. And we get to 20 million years ago when the real business starts. You can totally see it's splitting apart. 10 million years ago, all the Miocene. and about the last ice age. And you can almost see a new ocean forming right there, but you can also see evidence of the Rift Valley forming, which would be right around here. The end, and give credit where credit's due. Okay, so why is this area rifting? There are a lot of theories, but what we think is happening is that there is a mantle plume underneath the lithosphere, and we think this is a kind of debated topic. We think that the lithosphere was thinning due to plate tectonics, and that generated volcanic activity, which increased magma intrusions in small plumes. So the plumes further thin the lithosphere, and then it becomes like a feedback loop. Another thought is maybe there is a super plume underneath Africa, but these things are still contested. But I think if you look at the picture, you can tell that if there was a plume underneath the lithosphere, it would be thinning this lithosphere, and then the crust would be thinning and splitting, and it could possibly result in what we see now, which is a rift. This is an example of the Rift Valley in Tanzania. We don't see things exactly like this in Kenya, but this is a result of the lithospheric thinning and the rifting. And right here I have some definitions in blue, just in case you don't know what a mantle plume is. There are a number of consequences of rifting. You can imagine that all the heat from the mantle plume and the fracturing and expanding of the Earth will present something. And in our case, we get rift lakes, which result from the subsidence or the sinking of the Earth's crust due to faulting. And we also get volcanoes. As you can see in this map here, the red circles are volcanoes, the blue circles are rift lakes, and this is the whole Rift Valley down here. It's much bigger than this, but this is just a part in Kenya. So the blue, like I said, the blue circles are lakes, but we have this very large Lake Turkana up here, and that's the area that I do my research in. Here, there's a couple of the volcanoes that exist in Kenya. This volcano right here, which is active and had activity in 1921, is part of the barrier complex, which is right there at the bottom of Lake Turkana. And then there's Mount Kenya, which is the highest mountain / volcano in Kenya. And Kilimanjaro is technically in Tanzania, but it's so close to the border of Kenya that I think that we can count that, and that's the highest mountain in Africa altogether. And then there's the Menengai, and that is, it's a little bit cut off, but it's right there, and that's what that looks like. And then, like I said, other consequences of rifting are rift lakes, and these areas around these rift lakes, which are here in blue, have been studied intensively by geologists because there seem to be a lot of fossils and artifacts and things that our ancient ancestors used, and they seem to be dispersed around these areas where the lakes are. Like I said, this is where I work, Lake Turkana up here. Another important fact about Lake Turkana, and thus the fossils that we find there over time, is that it didn't always through time look like it does today. This is what it looks like today. This is what it looked like through time. Now, this is 4.5 million years ago. It was just a floodplain. So this is the outline of Lake Turkana in black, the way it looks today. And these little lines here are just rivers that are flowing through what would currently be the river. So 4.5 million years ago, it was a floodplain. But then 4 million years ago, it was a lake again. And look how much bigger. It's in the dark green here. Look how much bigger it is than the current Lake Turkana, and that was the Monument Lake. And then about 3.5 million years ago, we have a new configuration of the lake called the Lokachat Lake. It was a little bit shorter lived, but it was still much bigger than what we see now. But then 3.4 to about 2 million years ago, we have the Tulare floodplain. Now, this is sort of the time period that I work on. I kind of work from 4 million years to about 1.7 million years, but this is a big chunk of the geologic time that I work on. So there was just a floodplain with, some rivers going through it. And then if you notice this is a volcano. And I'm going to talk about this volcano later. So just keep it in your memory, its location, and it has something to do with something that we are going to talk about later. Then we have the Lorenyang Lake, which was from about 2 million years ago to 1.6 million years ago, and that was very big and very important for human evolution because this is the time that we find evidence of Homo erectus. And then from about 1.5 million years ago until we really get good evidence in the Holocene, we don't really know what's going on because there are something called disconformities and missing time, just geology that we can't find that might have been eroded away, or just things that we can't find. So we're kind of still questioning this time period, but we know at least that there was a floodplain here at this time. So, and I just wanted to go back real quick to the lakes and the volcanoes. Here is me swimming in Lake Turkana when I was working in the field. So sometimes we do have time for ourselves and time to have fun. So that's Lake Turkana in the background. And I also did get to go see a volcano, this one here, Mount Longonot. This was last active in 1863, but when I went there, I could see smoke coming out of little holes in the volcano. So that was pretty cool. I climbed all the way to the top. This is me at the top. I am so happy because it was really, really hard to climb 9,100 feet. And then there's a photo of a volcano that's actually in the middle of Lake Turkana. It's called Central Island. And I took this picture from a plane when I was flying over. So this is definitely cool too. Okay. So in order to understand what we're going to be talking about, we need to understand the depositional environment. So back to the rifting consequences, besides volcanoes and lakes, the areas that were higher than the valleys created by the rift eroded and filled the valleys with sediments, and as we know, sedimentary rocks are where fossils are found. This is why the African Rift Valley, and in particular Kenya, is such a good place to find fossils and artifacts. So the environments that the fossils are found in are sedimentary depositional environments. That includes river or fluvial, which is what we call it. We also have lake environments or lacustrine. We have alluvial fan areas, which is not exactly a depositional environment, but sort of we would just call it alluvial, but this is like when a massive sediment comes down from a higher point to a lower point. And then, of course, we have deltas, which is just where rivers enter the lake. And this is a picture of the sedimentary expression of an ancient delta. So these are the kinds of things that we see in Kenya when we're looking for fossils or artifacts. Now, one other important thing that you need to know about Turkana or about Kenya in terms of studying the geology is not quite a depositional environment, but it's kind of rock. And this is volcanic tuff. Volcanic tuff, or the general term tephra, is pyroclastic material erupted explosively from a volcano. So you can imagine like the lava coming out of a volcano. At some point, it hardens, it becomes a rock, or it becomes ash, or different kinds of things that we have words for. But what I'm going to talk about is volcanic tuff, which is a sedimentary rock that consists of more than 50% volcanic material, such as ash. Now, we see this all over Kenya. And this is so important to our study of geology because we can actually use the volcanic tephra to date the rock formations there. Geologists use minerals or glass shards in the ash to date the tuff, and then once you date that small area of tuff, like right there, the white, that's tuff. The white right here is tuff, the Tulu Bore tuff. This is the Calachoro tuff. This is the G3 tuff in Calachoro. And this is a piece of pumice, which I think you guys have all seen, pumice. Pumice is a very important thing for us to find because it's easy and helpful for us to date it. Now, using that volcanic tuff, we can construct something called a stratigraphic correlation. So these are all the different formations that are around the Turkana Basin, and all of these lines that you see that are going across, they're mostly horizontal, but some of them are going up like this, some of them are going here. These are all volcanic tuffs that have been correlated in different areas. So the Shangora Formation is in Ethiopia, but they have the same volcanic tuff as we see in the Nachukui Formation in Kenya, where I work. The same tuff is found in the Kubifora Formation, which is totally across the lake on the east side. And we see it in the Kanapoi Formation, which is on the southwestern tip of Lake Turkana. So we can use these tuffs, we can analyze them, and we can figure out how old they are, where they belong in the stratigraphic succession, and therefore figure out how old the rocks are, and then figure out how old the fossils are. So volcanic tuff is probably the most important thing that we look for when we're out in the field doing geology. So where I work at is Lomekwi on the western side of Lake Turkana. And like I said before, the time is about 3.6 to about 2.6 million years ago. So I worked during the time of the Paleo Lake Monument, the Paleo Lake Lokachat, and the Tulu Bore floodplain, like I showed you before. However, many fossils come out of younger times from about 2.3 to 1.7 million years ago. Much of the geology of the Turkana Basin looks like this, which is an example, these two are an example of an ancient alluvial fan. Very hard to tell, I guess. It kind of all looks the same, so you have to have a keen eye and you have to see a lot of things before you can start recognizing what these geologic formations represent. This area in Lomekwi, which is called Lomekwi 5, has been very fruitful in terms of hominin fossils and stone tools. And this area is about 3.3 million years old. So the paleontologists are still finding a lot of hominin fossils and fossils of other animals in this area, especially cows or bovids, like we call them. There's pigs, turtles, crocodiles, big and small fish, hippos, camels, rhinos, even mice. All of these different fossils show that the environment was dynamic, or it was changing, and it was changing often. So, like I said, fossils of many ages have been found around Kenya. Everything you see on this map that's in green were hominin fossils that were discovered in Kenya. Now, a hominin is a human. A hominid includes orangutans, gorillas, chimpanzees, and human beings. So we're both hominids and hominins. But hominins are human, so these are where the hominins have been found. So there's so many of them around here, and up here in red is are the hominins that were found in Ethiopia. And you can tell that most of these fossils are clustered around the lake, which is interesting in itself. So in terms of the oldest fossil found in Kenya, it would be Auroran, which was found in the Tugan Hills in the Lukino Formation. This fossil is about 6 million years old, which is very, very, very old, but we don't have any real reconstructions of it, so we don't know exactly what it looked like. We know things probably, you know, approximately how big it was, but unfortunately, we don't know that much about it because the fossils are stored at a secret bank vault in Nairobi. No one knows where that vault is. Nobody knows why it's there, so that's a mystery in itself. And another fossil that they found in this area was Dinotherium. which is a scary sounding name, and I think it's just because it's this gigantic elephant type creature. You could see how big it was, because this person is about 5.5 feet tall, and this is the Dinotherium, or the elephant type creature, which is pretty cool. So hopefully maybe one of you guys, if you become a geologist or a paleontologist in the future, you can find out more about Auroran, maybe find more fossils, or find where these fossils are in their secret vault. And the next oldest fossil that we find in Kenya is Australopithecus anamensis. And this was found in Canopoi, and Canopoi is the first place I ever did my field work. So I have a very special place in my heart for it. In this area, the geology is mostly river and lake. There's 3 main layers: river, lake, and then river, except there's a lot of tuff there, like I talked about before. So this is very important for dating the area. So we have the Canopoi tuff here, which you can see in sort of like white or a light yellow. On top of that is the Calaquania basalt, which also sometimes basalt can be dated, but tuff is usually more important. And then down here we just have mixed in with the tuff, and below the tuff we have river and lake sediments. This here is a reconstruction of Australopithecus anamensis, and these are some of the bones that were found. And then I think that the most famous, or the most important fossil that has been found in Kenya is Turkana, which is Homo erectus. It's very important because it was a pivotal point in human evolution. It was the most complete skeleton ever found. You can see it right here. That is pretty complete. It was found by Kamoya Kimu on the Nariakadame River floodplain. And this is an example of a floodplain, which is just the ground next to a river, which is formed of river sediments, and it floods often. So it's just like a river. When a river floods, it comes out of its bank, and then that land on the side is the floodplain, and that is where this skeleton was found. And the geology there is dated to between 1.9 and about 1.6 million years old. So this chart is showing us other animals that have been discovered in Kenya. Now, there's many animals that have been discovered alongside of our ancestors, and this timeline here goes from 5 million years to the present. These pictures down here are not exactly representative of the types of animals that were found then, because most of them are extinct. But here we have the elephant type creatures, which you've already seen in Dinotherium. And then we have perissodactyls, which are like horses. And right here is a pretty cool one that almost looks like a zebra, but it's a horse. We have rhinos. And then we have primates, or old world monkeys. So this one is an old world monkey. There's giraffes. And there's pigs, or warthogs, and this here is a Cape buffalo. And there are very many artiodactyls, but these are sort of like gazelles and things of that nature. There's so many of them that I didn't have enough room to put pictures, but you can refer back to this and see the huge number of animals that are found in Kenya. Now, something that people don't always associate with Kenya is dinosaurs. Recently, quite a few dinosaurs have been discovered there. And some examples I have here are the pterosaur. And you can see this is the pterosaur. You can see how big it is because it's next to a T-Rex. And then there's a person down here. So this is a very big flying dinosaur. And then we have another one of the Abelisauridae genus, which has not been named yet, but it's been called Titanovenator kenyaensis, which I think is pretty cool. And this is an example of the skeleton. Also found there in Kenya is Spinosaurus, and Spinosaurus, I think, is the second biggest dinosaur that we have found so far that existed. This is just an artist rendition of it. And then Titanosaurus, which you can see here is there's a person here who's about 6 feet tall, and there's Titanosaurus, so you can imagine how big that one was. These dinosaurs have all been discovered in the Cretaceous sediments of Lokiton Gorge. Over here, I have a picture of the Earth about 65 million years ago, and here's Africa. You can see Africa kind of looks sort of the way it does today. There's a little bit more water here, but you see this green area here is telling us that it was a little bit more moist and less desert-like, because Kenya's down here. The dinosaur bones were actually found in the Lapur sandstone, which is right here. And then on top of the Lapur sandstone is a basalt formation. You can see these little columns, that's columnar basalt, and that's Lokiton Gorge. So on top of this sandstone where all the dinosaurs were found is this cool gorge that you can drive through. So who knew that dinosaurs were found in Kenya? Also found in Kenya, a desert whale. So there's evidence of a desert whale found in Loperat, which is southwest of Lake Turkana. Now you can see how far inland from the ocean Loperat is. So we're wondering, how did a whale get all the way here? It's about 400 miles. So just quickly about the whale. It is a beak-nosed whale, which actually kind of looks like a dolphin, but that's because it has this thing called a rostrum, which is like a beak with teeth. So that's it's actually a whale, and its habitat is the deep ocean. So if its habitat is the deep ocean, which is down here, how on earth did it get all the way up by Lake Turkana? So what we think is that at some point, about up until 2 million years ago, there was a river that we call the Turkana River, and it went all the way to the coast and emptied into the Indian Ocean. So you can imagine the Turkana, Lake Turkana is up here, and then there's this Turkana River that is going all the way to the Indian Ocean. So I guess, or we guess, that this whale was in the Indian Ocean because that's its habitat, and then it just swam up the river and then ended up near Lake Turkana, probably, you know, in a floodplain or something like that. And the reason why it wasn't so obvious is because here is this volcano that I was talking about before. This is Mount Kulal, and this kind of was erected around 2 million years ago, and this blocked out any exit of any rivers to go to the Indian Ocean. So we find a lot of different kinds of like oceanic and marine creatures in Kenya that must have gone up this ancient Turkana River that doesn't exist anymore. But then, you know, at 2 million years, that stopped because this big volcano kind of blocked the exit. And here's another picture of what this proposed river would have looked like. Here's the outline of Lake Turkana, and then this river going out. Poor whale. Finally, I think one of the most recent and coolest finds was Simba Kubwa. This was just in the news a couple months ago. It is a very big lion. You can see this is a person right here. This is a lion next to the person, so you can see the size. This here is the jaw of the lion, and for comparison, this is a modern day lion. So this is a lot bigger than this one. And my favorite quote about this article was that Africa's largest mammalian carnivore had canines the size of bananas. So this canine is the size of a banana. So just think about that for a second. Very scary, very ferocious, but totally awesome. And that's all I have for now. So if there are any questions, I would love to hear them. Okay, I do have. Can you guys still hear me?
Yeah, you can stop sharing your screen because we still see your PowerPoint. Now you're muted, but
How's that?
there you go.
All right. So, okay. I'm just looking in chat really quick. Wasn't Titanosaurus from Lila? Wasn't Titanosaurus also found in Argentina? Is that evidence of continental drift? Yes. Titanosaurus has been found in a number of places, and it is exactly evidence that the continents were much closer. Certain continents were almost attached to other ones. So you find dinosaurs in New Jersey and you find the same dinosaurs in Morocco or the Netherlands or something like that because the continents were in a different configuration then. So that is exactly true. Let me go to the Google Doc here. I have Ramon from Magnolia who wants to know how many years does it take to dig up a dinosaur fossil? Well, that depends on what kind of dinosaur it is. If it's a very big dinosaur like a T-Rex or any one of the dinosaurs I just talked about from Kenya, um, it could take many field seasons. Usually field seasons are in the summer, and that's about 3 months long. But to dig up something very big, it could take very many years. You can imagine just chipping away. You have little brushes. You don't want to break anything. And then actually another time-consuming thing is just getting the very large dinosaur out of the area that it's in. And I've actually seen helicopters flying huge dinosaurs encased in plaster, helicopters flying them away to the museum. So if it's a big dinosaur, it takes quite a long time. You also ask, how many years does it take to become a paleontologist? Well, I have some very good information from somebody that says as soon as you find a fossil, you're a paleontologist. So it could just take, however long it takes you to find a fossil. But if you want a piece of paper that says you're a paleontologist, I would think that you just have to get a degree in college, which would likely be geology, but any science can usually get you into paleontology. Um, biology is a good one. Uh, I think that there are a couple colleges in the US that offer masters in paleontology. So I guess the shortest amount of time would be, the shortest official amount of time would be about 6 years. Ryan from Lenoka Harbor would like to know what type of mammals lived alongside our hominin ancestors in Kenya and how do they influence our evolution? So in my presentation, I showed you a bunch of the animals that lived alongside of our ancestors. But I think that the most important influence on our evolution was when we began to eat meat. So that was probably about, I don't know the exact date, but maybe it was about 2.6 million years ago. But I would think that our first ancestor that actually ate meat was, or consistently ate meat was Homo erectus. And if you see after that, our brain size continues to grow. And I think that would be the most important influence on our evolution because that made us into what we are today, which is Homo sapiens. Hey, Mary from Scotch Plains would like to know, how can you tell if a fossil was buried by water, wind, sand, or something else? So you would have to look at the context of the geology in which it was found, which is my exact job. If it was buried by water, you would find evidence of water. You would find something that we call lamination or sort of like lines or some sort of evidence of flowing water. You would also find the same thing if it was buried by wind. And now you see a lot of wind or Aeolian deposition in the Grand Canyon area. They're very large um, laminations that go, well, the stratigraphy just is diagonal. But if it was buried by sand, which is one of your questions, it could have been buried by water or wind, because sand would need some sort of medium to carry it. So if it was buried by something else, I guess you would have to figure out what kind of sediment it was. So if it was in mud, that could be water. If it was sand, that could be water too. So it really depends on the structures that you see when you find a fossil. What other forces moved the ground in Kenya before the fossils were discovered, like uplift? The forces that moved the ground in Kenya were mostly extensional, which means that they were pulling apart. So we have a lot of faulting. There's faulting everywhere. There are all different kinds of faults, but most of the faults that we see there are normal faults that are next to each other that create something called a graben, which is sort of just like a lowered portion of the earth with two higher portions on the side. So you can imagine it kind of looks like a valley. So most of the forces going on in Kenya were tectonic extensional forces, or sort of like a drifting, not a drifting, but a stretching apart. Let me just quickly go to Leela. Oh, I answered your question already. Maya would like to know, how do you date specimens? Do you use specific tools or take them to a lab? If we want to date the tephra, we prep them in our own lab. So I just prep them at Rutgers, but then we have to take them to a place that has a mass spectrometer that can analyze the different elements that are in the that is in the tuff. In terms of like an actual specimen, you would have to, because these are older than like 50,000 years, you can't use something like radiocarbon. You would have to look at the area where they were taken from, see if there's a tuff that is close, see if there is any other sediment or I guess bone material that could be dated. But the problem with dating actual bone material using radioactive dating is that you destroy it. So we try not to do that, or paleontologists try not to do that. We usually just try to date the geology around the area. So sometimes it's going to be relative dating because that's all we can do. But that's why we look for tuff so often, because we can date it in a laboratory um, by looking at the elements. Okay, Chris from New Brunswick wants to know, hi, Melissa, can we drill pores in lakes like we do in the sea? Thinking back to Dr. Adamo's talk. Actually, yes, we have drilled many cores around Lake Turkana. There is a project called HSPDP, which is the Hominin Sites and Paleo Lakes Drilling Project, where they actually go to areas of paleo lakes, take a drill a huge core of sediment, rather than ice or something like that. And it gives you the same type of information that a core in the ocean would. So that's actually something that I'm working on for my dissertation. We can see things in those cores that we can't see in the outcrops because there's no erosion, there's no environmental degradation that happens above ground. Of course, there's some issues that happen underground, like diagenesis or like a changing of the sediment, but it's much less apparent than the sediment above ground, which gets eroded by all the environmental conditions. So yes, that's a very big thing that we like to do. James would like to know, how did you and your team choose the spots you look for what? How did you and your team choose the spots you look for what you look for? Well, at this juncture in my life, I don't choose anything. So I go with the people who choose. They choose the spots by either scientists have worked in this area many years before and never finished it, but they knew that there was a lot of good stuff there. But when you think about it, Kenya is huge, so it takes a lot of time to look at everything. So you can go back to old spots where people found things and look there again, or you can say, well, there's so many of these Australopithecines were found in alluvial fans. Let's look for alluvial fans in other areas. So you would just go to sedimentary depositional environments where that have been productive in the past. But mostly it's just sheer luck. You know, you're just looking around an area. You're like, let's go to West Turkana to this area and just see if we see anything. And then, you know, you get lucky and you find a hominin cranium, and it's the greatest day of your life. Leela would like to know how many types of actual dinosaurs have been found. Well, actually, in total, there are about 700 named dinosaur species. Not that many seem to have been found in Kenya. I think as of now, there have been 5, let's say, genera of dinosaurs found in Kenya, and genera is one notch above a species, like Homo sapiens. Homo is our genus. So they found many, about 5 genuses of dinosaurs in Kenya, as far as I know. But like I said, it's a kind of a recent endeavor, and they haven't really gotten around to like naming them. And I'm sure there are tons more that are waiting out there to be found. Ria's mom would like to know, have you seen any snakes during your field work? Black mambas? I actually never saw a snake during my field work until 3 months ago. Um, it was not a black mamba, thank God. It was, I was going to measure the strike and dip on this piece of sandstone, and one of the fossil hunters, Robert Maru, who was with me, was just kind of whistling, looking for some, you know, fossils, and he said, "Oh no, Melissa, snake!" And of course, I didn't know where the snake was, so you know, I screamed as loud as possible and ran away. So I found out that that snake was right below the sandstone that I was trying to measure. I have a picture of it. I wish that I could bring it up right now, but it wasn't very big. Actually, I thought it was kind of cute, but yeah, we try to stay away from snakes because black mambas are will kill you in 15 minutes, and that's not enough time for flying doctors to come out and get you. So we try to be very cognizant of snakes, and clearly my experience a couple months ago was a learning experience that I should check before I measure. See, Bill would like to know, how was the fossil man Rudolfensis found? Did he appear to be in a burial site or other situation? Um, Rudolfensis, I don't know that much about, so I will have to get back to you on that. Um, oh, one of my secret helpers is telling me Russian scientist VP Alexiev named the species in 1986 after Richard Leakey's team uncovered Homo rudolfensis fossils near the shores of Lake Turkana in 1972. Um, I don't know if it was a burial site, but I wouldn't. I feel like we just don't know enough information about that yet, and I think that maybe burials didn't start until Homo neanderthalensis, but I'm not a expert on that, so I really don't want to answer that question. But I will find out and let you know. Maya would like to know, what do you consider your team's greatest discovery? Um, I don't know if I can say exactly what it was, but a couple years ago we discovered something that we discovered a hominin, and I think that, a paper is going to be coming out soon, but it was a very distinct hominin, and it was one of our greatest days in the field, and we were so happy that we had a party afterwards, and we had chapatis, which was my favorite food. So while I can't tell you exactly what it was, you will probably hear about it in the next year or so. So stay tuned. James would like to know, do you have to compete with other universities over the sites you explore? If so, how do you deal with that? That's a really interesting question. In Ethiopia, you have to get a permit for a specific site that's like 100 meters by 100 meters, and you cannot go out of that site. In Kenya, you get a permit for like a general area, and even if you go out of that area, it's not that big of a deal. Nobody's patrolling it. The more important thing is that you have to speak to the chief of the area before you start exploring it. So you have to make you have to do good customer relations, and sometimes the chief and the people of that town will help you. But do you have to compete with other universities? You have to compete with other universities in terms of getting funded for whatever you're proposing. So yeah, you would have to compete with other universities, but usually we all kind of have this like unspoken agreement, like certain people or certain universities or certain groups of people work at certain places. So at least in Kenya, it's not too bad. But I know that in Ethiopia, it's very specific, and you have to do a lot of legwork to be able to work in your tiny little specific area. Maya would like to know, do you know anything else about the leakies? Um, so after we have dinner, sometimes there's late night, talks. So do I know anything that I'm gonna say on Ask a Geologist? No. But I have met Richard Leakey, who told me that I should put more sunscreen on and I should cover every part of my body up because of skin cancer, which he actually showed me that he has pretty bad. And you can tell that I was not made for the sun in Kenya. So I do wear clothing from head to toe, and I wear a lot of sunscreen, and I reapply it every hour. I've met Meave Leakey also, who is very interesting. She's probably about 74 years old, and she hops around like she's a 30-year-old. She's very um, active and quick and sort of adorable. But other things about the leakies would just be gossip, and I'm here to talk science. Maybe someday. Why did I decide to become a geologist? I decided to become a geologist because of Jurassic Park, and I'm talking about old school Jurassic Park. I'm a 90s kid. So I saw that movie and I was like, wow, I can actually do a job where I can look for dinosaurs. I didn't even know what that was. And then when I first started college, I thought it was actually archaeology. But then I found out that it was geology. And then I didn't think that I was good enough at math to do it. So I just switched my major to English. But I still felt geology calling to me because I wanted to understand why things started and how things started. And I said, if I'm gonna do anything, this is what I'm gonna do. So I went back to geology, and then I actually found out I was good at math, and I love it, and it's like my one of my favorite subjects. So never let anybody tell you you can't do something, including yourself. What is my favorite part of traveling to Kenya for my research? My favorite part is the people, really. Everybody there is so nice and kind and happy and welcoming. Um, I also love their food, which is not, as diverse as something like Ethiopian, but chapatis and ugali, which is like polenta. I just I don't know, I love it. The climate where I work is not the greatest. It's like usually 100 to 110 degrees, but it's a dry heat, so the humidity is very low, so it's not so bad. Um, but I really do love everything about Kenya. Just being out there in the geology, the nature, the birds, which I have a huge thing for birds. Um, Everything. I love it. I can't, and obviously I can't go this summer. And I'm so sad about that, but hopefully I'll be able to go soon. Um, what have, oh, Austin Lawrence. I think I've worked with this person before. What have been your most rewarding and most challenging experiences doing field work? My most rewarding experiences are when I figure something out, when I'm looking at some kind of exposure of rock, and when I first look at it I have no idea what it is, what it means, what it's, what it represents, and then I leave and I come back a little while later and I'm like, oh my god, this is a lacustrine formation or evidence of a river, or oh, look at this fault here, how did I miss it? So like I don't have one specific rewarding thing, but whenever I figure something out after thinking about it for a really long time, that is my most rewarding thing. My most challenging experience, I think he would know that the last field season that I was at, which was about 3 months ago, it rained for almost the entire time we were in the field. Now, Turkana is a desert. It never rains, and when it does, there's specific seasons in which it rains. Excuse me. But this year, for some reason, it decided to rain after the rainy season, and we were camped on a river, a dry riverbed, which is ephemeral, which means it only fills up once in a while, and that's usually during the rainy season. But this time, it filled up 10 times, and it overflowed, and all our stuff got wet, and our clothes didn't dry, and my computer died, and everything that could go wrong went wrong because we were not prepared for rain. So that was my most challenging experience, learning how to do field work in the desert when it rains. And because of, I think Lauren might want to, Lauren has a question there that things might be wrapping up.
Oh yes, you can do one more if there's another question.
There is a couple. Mary from Scotch Plains would also like to know, what new instrument would you like to see for your work? I would really love to learn how to use drones. A lot of people are using drones now. You can just send it up and fly it over the whole area, so I don't have to hoof it for like, tens of kilometers, hundreds of kilometers. I would do that anyway, though, because I love it. But it would be so nice to be able to just get a shot from above that isn't from a plane, that's a little bit lower. So totally want a drone. I would love an instrument that I could just point it at a rock and it would tell me the constituents of the rock, like what kind of minerals and mineral percentages. I think that exists, but it's like $1 billion, so, and it's also kind of cheating. Um, what is the smallest fossil in Kenya? Mary from Scotch Plains is asking. I don't know the actual smallest fossil, but there is a lot of like micro archaeology that goes on, and I know they find like tiny little teeth of like mice. So you can imagine like how small a mouse is and how small a tooth is. I don't have any knowledge of like things like bugs or anything like that being preserved, but we know that bugs are preserved in amber. I just haven't seen any of that, so I'm not exactly sure what the smallest fossil is, but I know that the smallest there's a tiny monkey that was found recently called a lessie, and its skull is like this big. It's very small and cute. Um, are there any fossils that have not been identified yet? Um, there are so many questions, even about the things that we say that we have found. Like they found something called Kenyanthropus platyops in Lomekwi in West Turkana, and people still don't really agree that it's Kenyanthropus platyops or if it's Australopithecus afarensis, or if it's something else, or if maybe everything is just related and there are just small differences. So there's nothing that hasn't been named as far as I know, but there is no consensus on the ones that actually have been named. So I hope that answers your question.
Okay, thank you so much, Melissa. That was great. And thank you to everyone who was listening today. Please don't forget to join us on next Tuesday, May 5th, to hear Dr. Carrie Ferraro speak about ocean zones, and that will be at 2 p.m. So thanks again, and bye.
Thank you, everyone.